We once sent a message in a bottle out into the cosmic ocean. Seriously. On the Pioneer space probes, we attached a plaque with a map, a guide for any intelligent life to find their way to us. And this map uses 14 pulsars as, like, galactic lighthouses. Well, it turns out one of those lighthouses, a pulsar named B1727-47, was hiding a pretty big secret. It was a runaway, a cosmic fugitive that was breaking all the speed limits. So our story kicks off with a measurement that just didn't make any sense. This pulsar, which we've known about since 1968, is one of the brightest young pulsars out there. But when astronomers first tried to clock its speed based on how far away they thought it was, they got a number that seemed, well, basically impossible. Yeah, that's the number they came up with. Roughly 1,900 kilometers per second. That's almost 4.5 million miles an hour. Just let that sink in for a second. To give you some perspective, you could get from LA to New York in the time it takes to blink. For something as massive as a collapsed star, moving not fast isn't just a little weird, it's a huge problem for, our entire understanding of how these things work. So that became the central mystery, right? I mean, a typical pulsar might be zipping along at around 250 kilometers per second. This one was supposedly going more than 7 times faster than that. We know supernova explosions give these things a massive kick, but a kick that big, it would pretty much challenge everything we thought we knew. Something had to be wrong with the numbers. And the prime suspect for what was wrong was this technique, the dispersion measure. Okay, think of it like this. A pulsar's radio beam travels to us through space, and it has to pass through these clouds of electrons. This stuff acts like a kind of cosmic fog that slows the signal down. By measuring that delay, astronomers can estimate how far the pulsar is. But what if there's a really thick patch of fog out there that you just don't know about? That's exactly what they started to think was happening here. All right, so with this crazy high speed on the books, astronomers had to basically become cosmic detectives. They needed to go back and re-examine every single piece of evidence. And that meant digging through decades of old observations to track this pulsar's tiny little movements across the sky.
And this just shows you the incredible patience you need for astronomy. This wasn't a quick Google search. We're talking about combining 21 years of timing data from one telescope with 12 years of super precise position data from another. They were meticulously building their case, observation by observation, year after year.
But of course, the pulsar didn't make it easy for them. Its spin is really unstable. It has these frequent glitches where it just suddenly speeds up. It's also got a ton of timing noise, which is kind of like static that messes with its otherwise perfect rhythm. And on top of all that, they had to figure out how to account for tiny little differences between all the telescopes they used over half a century. It was a really messy puzzle to solve. But here's the cool part. By carefully layering all these different messy data sets on top of each other, they could cross-check everything. You can see here how the measurements of the pulsar's proper motion, that's just its tiny apparent movement across our sky, start to line up. The first guess was way down at 111, but by combining everything, they nailed it down to a much more confident 148 milliarcseconds per year. Okay, so now they had a really solid measurement of its movement. The next question was, where was it moving from?
So now, with a precise trajectory locked in, our detectives could finally survey the neighborhood. And that's when they spotted it, a huge potential crime scene sitting right in the pulsar's path. Right there on the edge of this gigantic ancient cloud of gas called RCW-114 was our little pulsar. Now, RCW-114 is a supernova remnant. It's the ghost, the leftovers, of a star that blew itself to bits tens of thousands of years ago. And it is absolutely enormous, covering an area of the sky 8 times wider than the full moon.
Suddenly, the pieces were starting to click into place. You've got this tiny, super dense star just rocketing through space, and you've got this massive, expanding cloud of debris from a star's explosion. Could they be related? Is it possible the explosion that created this massive remnant is the very same one that launched our pulsar like a cannonball? This was it, the critical moment in the whole investigation. They had their suspect, they had the crime scene, and now they had the trajectory. All that was left was to connect the dots and find that smoking gun. And the final move was just beautiful in its simplicity. With their new super precise measurements of the pulsar's motion, they could just hit rewind on the universe. By tracing its path backward through space for about 80,000 years, they could see exactly where its journey began. And there it was, the smoking gun. The pulsar's trail led directly back to the heart of the supernova remnant. Case closed. There was absolutely no doubt anymore. This pulsar was born in the very same explosion that created that giant nebula. They were a cosmic match. Now, solving this one cosmic speeding ticket had way bigger consequences. Because proving the pulsar was connected to that nebula didn't just fix the speed problem, it actually forced us to redraw our map of the Milky Way. So here's how it all fits together. We knew the supernova remnant, RCW-114, was much closer to us. By linking the pulsar to it, we suddenly had a new, correct distance for the pulsar too. Instead of being way out at 2,700 parsecs, it's only about 700. And when you plug that new, closer distance into the speed formula, that impossible 1,900 kilometers per second drops down to a much more believable 500. Still ridiculously fast, but totally possible with a supernova kit. And this is really why it all matters so much. We didn't just correct the distance and age of a famous pulsar. We proved that the original distance measurement was off because there's a thick, foggy clump of interstellar gas in that direction. Our old maps just didn't show. And we sealed the deal on a direct link between a dead star and the explosion that created it, giving us a perfect little laboratory for studying how stars die. It really leaves you with an amazing thought, doesn't it? This one pulsar, hiding in plain sight for 50 years, completely changed how we see its little corner of the galaxy. It just makes you wonder, what other cosmic secrets are out there just waiting for the right set of eyes to finally crack the case?